Next, let's look at the inner product of this Eisenstein series at level 1 and parameter lambda with our Poincaré series P sub L Z S bar. And here I'm going to write that this Eisenstein series E Z lambda has a Fourier expansion. We know what the Fourier expansion is, but I'm just going to write it like this. I'm going to write it C sub lambda 0, and then there's a y dependence here, and then it's going to be a sum n not equals 0, and I'm going to normalize it so that the C lambda of n here has this 2 in front, and then I'll have my y to the 1/2 k lambda minus 1/2 2 pi n y e n x. So again, checking with Matt Young, we can see that C lambda of n is equal to absolute value of n to the 1/2 minus lambda sigma 2 lambda minus 1 n, and then there's this denominator of the completed Riemann zeta function, pi to the minus lambda gamma of lambda zeta of 2 lambda. But the reason to write it this way is that when we do this calculation, well, the constant term isn't going to end up mattering because the integral in x is going to make this vanish, and we're left only with the Lth Fourier coefficient. And if this C lambda n were a rho j n, then we would have exactly the same Fourier expansion as the Moss form, right? Also, I guess with this lambda minus 1/2 replaced with IRJ. But so it's exactly the same calculation, and we can just write down what we had in the previous videos. This will be C lambda of L over 4 pi L to the S minus 1/2, and then our gamma functions are gamma of S minus 1/2, and then instead of IRJ we have lambda minus 1/2, so plus lambda minus 1/2 times gamma of S minus 1/2 minus lambda plus 1/2 all over gamma of S. And now we might as well stick this back in. L is assumed to be positive, so we can drop this absolute value, and we end up getting that the inner product here is equal to 2 times L to the 1/2 minus lambda sigma of sub 2 lambda minus 1 of L over 4 pi L to the S minus 1/2, and then the same, and then we have our completed zeta function, pi to the minus lambda, gamma of lambda, zeta of 2 lambda, and then we have our gamma functions. All right, so this is this inner product.